Hi everyone! In this video, we will perform and interpret a hypothesis test for a proportion using a calculator. A hospital administrator wants to evaluate the hospital's new online appointment system. The hospital claims that the system is reliable and available more often than not. The administrator monitors the system for a month and records whether it is operational each day. Out of 30 days, she finds that the system was up and running for 22 days. Use a graphing calculator to test whether the new online appointment system is more reliable than not at the 5% significance level. Because we are doing a hypothesis test, we should identify the two hypotheses. The null and alternative hypothesis are making claims with the proportion, so we use a p. We see that the claim is that they are more reliable than not. If they are not more reliable, then it's exactly 50-50. So the null hypothesis is 0.5. And the claim is that they are more reliable, so the claim is that it is greater than 50-50. A few more things that we've been told is that we have 30 days that were being observed. So the sample size is n equals 30. And of those 22 days, the system was up and running. So the number of successes is x equals 22. We were also told the significance level is 5%, so alpha equals 0.05. With our calculator, we're going to calculate the test statistic and also the p-value. Let's go ahead and draw a normal curve so we can visualize the hypothesis test. The alternative hypothesis says that it is greater than 5%, and it's pointing to the right. This is a right-tailed test, and our alpha or significance level is 0.05. So the area we're looking at to the right under this tail is 0.05. Let's go ahead and open our calculator so that we can calculate our test statistic and p-value to make a conclusion about our test. The first thing we need to do is go to Stat, and then we need to move over to the tests, and we're going to the one proportion z-test. We can arrow down or just press 5, and that'll just bring it straight up for us. The proportion for our claim is that it is more reliable than not, which is 0.5. The number of successes is 22 out of a sample size of 30. Our alternative hypothesis is a greater than sign, so we need to select the greater than, and then go down to Calculate and press Enter, which will give us our test statistic and our p-value. Let's go ahead and write those down. The p-value is 0.005, and the test statistic is 2.5, and let's just round it out to 2 decimal places, so it's 2.56. The p-value is a very small proportion of 0.005, which means it's going to be much smaller than our alpha of 0.05. In our comparison, we would say that p is smaller than alpha. This effectively puts it within the rejection region, which means that we reject the null hypothesis. This means that there was sufficient evidence to support the claim that the system is more reliable than not. And now we're all done.